Buenos noches, Algebra 2. Today we're going to be learning our final pieces of information for Chapter 7. We're in 7.8, which is entitled Negative Rational Exponents. And if you remember what 7.7 was, well, it was positive rational exponents. So there's not going to be much difference between this section and the last. You're still going to have fractions as your exponents. That's what the word rational means. The only difference then is we used to have positive and now we have negative, which, if you just remember when we first learned about negative exponents, you are just going to have a misplaced base here. So for instance, let's take an easy example and just to do a little bit of a review on this. So let's say we had x to the negative third power over y squared, let's just say. Now y squared is not a problem because we have a positive exponent, but that negative 3 has got to go. So if you remember what we did with this x to the negative third power was we just popped it downstairs. We had x then to the positive third power, and then we just wrote the y next to it, so y squared, because you can't really combine those because they have different bases. And then if you ended up with nothing on either top or bottom, you would just put a 1. Okay, so our answer then would be x to the third power, or excuse me, 1 over x to the third power times y squared. Okay, so now, just for instance, let's just say this was 3/5. So same thing, it pops it downstairs. It's still 3/5 though. Okie dokie. Example 1 says evaluate 81 to the negative 1/4 power. Now we've seen the rational exponent in the last section. Now we have negative 1/4 power. So all that means to do, just like we did in the first example, is 81 to the negative 1/4. Oops, 81 to the negative 1/4. That becomes 1 over 81 to then the positive 1/4 power. And then we just have to evaluate this. So this means instead of taking the 1/4 power of 81, we can think of it as the 4th root of 81. And that, you might know by now, and maybe not, that is going to be 3 for us. Now if you didn't know that, of course, we could bring this guy into play here and do 81 to the 1/4 power, or we could take the 4th root of 81 if you'd like. Either way, you're still going to get 3 either way. So instead of just having 3 though, because we had 81 on the bottom, we have 1 over 3, which gives us 1/3. So that's what that is, just 1/3. Alrighty, we're going to go ahead and simplify this this fraction here. We have 27 over 1,000 to the negative 2/3 power. So remember what that means to do is, well, each thing in here needs to get a negative 2/3 power because that is the property of parentheses here. So we have 27 to the negative 2/3 power over 1,000 to the negative 2/3 power. So both of those get a 2/3 power. So both of them have a negative too, so what happens is the 27 goes from the numerator to the denominator, and 1,000 here goes from the denominator up to the numerator. So they essentially, since they both get hit with that negative exponent, they switch places. And when they do, so you have 1,000 up top, when they do, that exponent then becomes positive. It's still 2/3. We don't do the reciprocal or anything, but we do take away that negative because we've placed the base where it now goes. So it's no longer a misplaced base. So 27 then to the 2/3 power. Okay, and you might be able to do these by just thinking about them here. We could break 1,000 down into 1,000 to the 1/3 power. So we're going to take the cube root of that, and then we're going to square it. And then we can do the same thing with the bottom. So I'm going to go to 27 to the 1/3 power, and then we're going to square it. All right, so let's break this down. Cube root of 1,000. Well, the only way we can get 1,000 and trillion and million and all that stuff is by powers of 10. Well, is the cube root of 1,000 10? Well, yeah, because you have 1, 2, 3 zeros, so that means 10 cubed is going to be 1,000. So the reverse is also true. So the cube root of 1,000 is 10, so then we have 10, and we still have to square it. Don't get excited, we're not done yet. So 10 squared, and then downstairs, cube root of 27. We've seen that before. That's going to be 3, because 3 times 3 times 3 is 27. And again, we still have to square that guy, so make sure your squared gets put on there as well. 10 squared, that's easy. That's 100. Downstairs, 3 squared, that's also easy. That's 9. And then you always want to ask yourself, because it says to simplify, is this as simple as it gets? Or is there a number that is a common factor of 109? Well, the only factors of 9 are 9 and 3. So that's not actually going to work because neither of those go into 100, so this is in its simplest form. If you needed to check that in your calculator, that would be just fine, but we now know that 100 over 9 is our final answer there. Okay, so the only difference between this and the last section is that we started out with 27 on top and 1,000 on the bottom, and since they were both negative exponents, they just flip-flopped. Okay. Example 3. The number of hours that pasteurized milk stays fresh is a function of the surrounding temperature T. Use the formula. Okay, so they give us a formula here. H of T equals 349 times 10 to the negative 0.02 T power. So we're in scientific notation here, but we also have an exponent here that is negative and has a variable in it. And they tell you where the temperature is going to be. T is in degrees Celsius. And we're going to use this to predict how long newly pasteurized milk will stay fresh when stored at a temperature of 8 degrees Celsius. So let's just say, for instance, your refrigerator was kept at 8 degrees Celsius. So you want to know, all right, if I have a gallon of milk in there, how long is it going to stay fresh? Because the worst thing in the world is opening up your fridge, and you just poured yourself a bowl of cereal, and you open up the fridge, and either there's no milk, which is possibly the worst situation, but the second worst situation you can find yourself in is that the milk has gone bad and you open it up and it smells funky, and I don't know about you, but I just cannot tolerate spoiled milk, so I throw it away and that's the end of it. So we got to figure out how long we want to keep the milk for, because sometimes it's questionable. Sometimes maybe it smells bad, but you're not really sure. So let's see here. We're going to use this here, and they give us the temperature, so they told us the temperature was T. So everywhere I see a T, I'm going to try and plug in 8 degrees here, so I can figure out what it is when it's at 8 degrees. So we have H of, here's the T, so that's H of 8, and then equals 349 times 10 to the negative 0.02 times T. So here's where another 8 gets put in. Okay. So negative 0.02 times 8, that is our power. Okay, now we know that that negative is going to make that 10 go downstairs. Now be careful, the 349 is going to stay right where it's at, but that 10 to the negative 0.02 times 8 power, that's got to go downstairs because of this negative here. Okay, so let's start simplifying this a little bit just before we go to our calculator. So H of 8 equals 349 times 10 to the, negative 0.2, or excuse me, 0.02 times 8 here is going to be negative 0.16, because 2 times 8 is 16, so 0.16. And then we could, if we really wanted to, we could rewrite this since we are doing negative exponents. Let's go ahead and do that. So H of 8 equals 349. Now the 349 stays. Now this 10 to the negative power, what that means is I'm going to put it downstairs. Now there's not a fraction already, but I of course can make one. So then 10 goes downstairs, and now it's not to the negative 0.16 power anymore, it's to the positive 0.16 power. Okay? Now you could argue that this is simple enough to go to your calculator with, which I would probably agree with you, but you know, since we were using negative exponents, we could write it this way. So either one you choose to put in your calculator, go ahead and grab those and see what we get here. So I'm going to do it the second way just because, you know, I did that. I'm going to use it. So 349 divided by, now just for good measure, I'm going to put this thing in parentheses. So 10 to the 0.16 power. And we hit enter and we get 241. So 241. Now you might be like, wait, days? That seems like quite a long time. 241 days, that's most of a year. That's not how long milk lasts. So let's discuss, let's write this down before we get rid of our calculators here. So it's 241.45, I guess we could write down if we wanted to round. So 241.45, my immediate thought was, oh, that's in days, but I didn't read my question very carefully because 241 days is ridiculous. We all know milk doesn't last that long. I wish it did, but it doesn't. If we look at our units here, it says the number of hours that pasteurized milk stays fresh is a function of this here. And that, of course, makes sense because we have H there. So that's the number of hours. So let's figure out, because I don't really know how many 241 hours is. So let's figure out how many days that actually is. So I can say, all right, it's been in there since Monday, it's Friday, we're good. Or vice versa. Let's say maybe it's 2 Fridays from then, and it's not good anymore. So if I have 241 hours and I need to convert that to days, then of course, how many hours are in a day? 24. So we divide this by 24. So 241. Now, if we just round this, because we don't need to be super exact here, 241 is pretty much 240 for all intents and purposes. The extra hour, 0.45, well, another hour, that's not going to make much of a difference. Divided by 24. 240 divided by 24, well, that's just going to be 10. So that's 10 days that our milk is going to last, which makes sense because that's a week and a half, and that's typically my milk anyway. That's about how long it lasts. After that, it starts getting curdly and gross and smells like bleh. So I just toss it. Get rid of it. Not worth drinking. All right. Example 4 says solve x to the negative 2/5 power. All right. Equals 9. So we could do this a bunch of different ways. What we could do was what we did in the last unit and actually just multiply by this guy's reciprocal. It just happens to be negative. We can treat them the same though. So I'm going to go ahead and rewrite our equation. So x to the negative 2/5 power equals 9. And we're going to do the same thing we did in the last section, which was take the reciprocal of this. Now reciprocal, remember, I want to keep the sign. So it's still going to be negative. So it's going to be negative, but then we flip these. So 5 halves. So negative 5 halves. Whoops. Whoopsies, that's supposed to be a 2. Let's go ahead and erase that there. Sorry about that. So 5 halves. And then, of course, what we do to the left-hand side in an equation, I have to do to the other side. So we go over here to the right and say we're going to take 9 to the negative 5 halves power. Okay? So, of course, these are going to cancel, and we're just left with x. So we have x to the negative 5 halves power. Now, we could, if we wanted to simplify this, put the 9 downstairs, because that's what the negative means. Take the, you know what, let's do this one by hand. We can actually do this whole darn thing by hand. So let's do that. I'm going to rewrite the 9 to the negative 5 halves power to 1 over 9 to the now positive 5 halves power. And then if you recognize, if I have a 2 down here, that's actually really nice because I can actually simplify that without really thinking all that hard. So I have x to the 1 over, now I'm going to break this apart. If I have a 2 downstairs, I'm going to write this as the 1/2 power and put the 5 on the outside. The reason I did that was because guess what? To the 1/2 power, well, we know that that just means square root. So we have x equals 1 over, well, the square root of 9 is just 3. So then we have 3 then to the 5th power, and we just have to figure out what that is. So x equals 1 over 3 to the 5th. So 3 to the 4th power we know is 81. So then 81 times 3, well, 1 times 3 is 3. 8 times 3 is 24, so that's 240, plus 3 is 243. That's 3 to the 5th power. You don't believe me? Check in your calculators. So we can leave it like that because we all know that I love fractions. So I'm actually going to box this guy up right here. Or I could actually figure out what kind of decimal that is. So 1 over 243. So 1 over 243. Enter. And that's 0.004. So just for those of you who like decimals, we can write that one down too. So we could say, or x equals 0.004. And that's, you know, an okay answer, I suppose. Now let's just double check that because, of course, if we get this as an answer here, it should, if I plug it all the way back in to our original problem, it should give me 9. Okay? So here's where you got to kind of make a decision. Do you want to use the decimal or the fraction? Well, since we rounded, we're not going to get exact answers, so I'm going to go back to the fraction. So I'm going to take 1 over 243. And I'm going to take that to the, well, in our original equation we had negative 2/5 power, so to the negative 2/5 power. And see if I get 9. Hopefully I do. Boom. There it is. So we know our answer is correct. Cool. And that is our last example for this section. So hopefully you'll come tomorrow ready to go. And since this is the last section, please don't forget you are going to have your test very, very shortly. So please make sure you are prepared. Thanks and have a good night.